औज़ुबिल्लाहिमिनश्शैतानिर्रजीम बिस्मिल्लाहिर्रहमानिर्रहीम। आज हम फिज़िक्स का फर्स्ट चैप्टर नए कोर्स का शुरू कर रहे हैं, दैट इज़ अबाउट द मेजरमेंट्स। तो ये फेडरल बोर्ड का नया कोर्स है और फर्स्ट ईयर के अंदर ये चेंज आ गई। तो मेजरमेंट्स में फिर स्टार्ट किया गया है डायमेंशन ऑफ द फिजिकल क्वांटिटीज, डायमेंशन ऑफ द फिजिकल क्वांटिटीज। So definition: dimension denotes or describe the physical nature, physical या qualitative nature of a physical quantity. Dimension denotes or describes the physical or qualitative nature of a physical quantity. For example, length, width, height, radius and circumference. All these physical quantities have same dimension because these have same unit. Different quantities with different units have different dimension. Dimension of a physical quantity are represented by a capital letter in a square bracket as given below. Dimension of length is written as follows: dimension of mass, etc. Now we discuss the dimension of base or fundamental quantities. In physics there are some quantities known as base quantities या fundamental quantities, and dimension of base quantity, name of quantity or dimension of that quantity. First of all, mass. So the symbolic representation of the dimension of the mass is length is represented by this capital letter L with the square bracket. Time is denoted by this capital letter T in a square bracket. Electric current is represented by I in temperature in terms of theta. This is the dimension. And intensity of light, this is denoted by J, capital letter J. Amount of substance, and this is dimension में N capital. These quantities 1, 2, 3, 4, 5, 6 and 7. These are the physical quantities known as base quantities or fundamental quantities. All other quantities in the physics like velocity, acceleration, force, momentum, work, power, energy, etc. All these quantities are called derived quantities, and all these are the combination, relations of these fundamental quantities, and we get the new quantity known as derived quantity. So now we discuss some examples of derived quantities, dimension of derived quantities. First of all, velocity or speed. Velocity or speed is the ratio between the distance over time or displacement over time. So, displacement having dimension length and time has dimensions t, and this is written as t minus 1 in the bracket. So, this is the dimension of this derived quantity. So, this can be written as another way also, m0 length or t minus 1. Similarly, acceleration is another derived quantity, and how we define acceleration as the rate of change of velocity. We can write change in velocity divided by time, and velocity have the units, and divided by time has the unit, has the dimension, not unit, dimension of velocity over time can be written as Lt minus 2, can be written as m0 length t minus 2, that is the dimension of acceleration. One more example at force. We know that force F is equal to ma, Newton's second law. M is the mass, A is the accelerations. So, since F is equal to ma, mass, dimension of the mass into dimension of acceleration is this one, and collectively can be written as m l t minus 2. This is the dimension of the force. In these three examples, we see that how three fundamental quantities, mass, length and time, relate to give new quantity like speed or velocity, and in this case this is accelerations, and this is the dimension of the force. So the way we can write the dimension of the physical quantities which are derived quantities and so on. Next, terms used in dimension analysis. Now we discuss terms used in dimension analysis. There are 4 terms which are used in dimension analysis. One is dimensional variable. Number 1 is dimensional variable. Those physical quantities which have dimension and have variable magnitude are different. Variable magnitude. Examples: distance, displacement, velocity, speed, acceleration, etc. Distance and displacement, same dimension of length. Velocity or speed, same dimension of length and time. Acceleration has the dimension of length and t minus 2. हमने ऑलरेडी इसको लिखा है, तो these quantities are called dimensional variable. And number 2, dimensional constant. The quantities, the physical quantities which have dimension, but their magnitude is constant always. Example में h known as Planck's constant, c speed of light, r universal gas constant, etc. These are dimensional constants. Physical quantities have dimension, but numerical values or magnitude is always same or constant. Number 3, dimensionless variables. Those physical quantities which have no dimension, but but have, for example, plane angle theta, solid angle, and strain. Theta is S over R, since S equal to R theta. Theta is S over R. S is the distance which is measured in meters. R is the radius which is also measured in meters. So meter divided by meters. So this quantity which we call plane angle taken in radians or degrees, this is unitless quantity. Similarly, solid angle phi, area of the surface, spherical surface, divided by square of the radius, 4 pi r square divided by r square. This is 4 pi. So this is again meter square over meter square. That's why there's the number 4 pi. This is unitless, and that's why no dimension of this terms which we call solid angle. And similarly, strain delta L over L or delta V over V. Length having dimension, same is the dimension of length. Numerator, denominator, same units. Delta V change in volume divided by volume, same dimension. So this cancelled, or this is strain is again dimensionless quantity but have different values. So these are some examples of dimensionless variable. And finally we discuss fourth term है dimensionless constant. Those quantities which have no dimension and have constant magnitude. Example, all integers 1, 2, 3, these have constant values but no dimensions. Similarly, pi having values 3.14 and is taken as constant and have no dimensions. So these are the terms which are used in this dimension analysis.